Welcome to another episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor.
Welcome, everybody, to another episode of our show. Today, bringing you another really awesome guest involved in creating a better tomorrow. Today, we have the honor of being joined by Dr. Legena Henry, who is a lecturer for renewable energy at the University of the West Indies, Cave Hill campus in Barbados, where she has a research program specializing in renewable energy, ocean engineering analysis, ocean wave statistics, as well as marine hydrodynamics and applied mechanics. Dr. Henry is also the chief executive officer and founder of a really interesting company called Rum and Sargassum Incorporated, which is a novel transportation biofuel company located in Barbados, where her research has been translated and ultimately focuses on sustainably generating usable power output from various natural resources from the Caribbean Sea, including Sargassum seaweed, as well as ocean waves. Dr. Henry completed her undergraduate bachelor's in mechanical engineering at Howard University, went on to do her master's in ocean engineering at the Center for Ocean Engineering at MIT, and then completed her Ph.D. research in mechanical engineering at the University of West Indies St. Augustine campus. Dr. Henry also serves on the MIT Educational Council. A lot of really cool and pertinent topics to get into today. Honored to have her with us. Dr. Legena Henry, thank you so much for taking time to come on the show.
Yeah, thanks for having me. I appreciate it.
Great having you. Would love to start off, as we typically do, by handing you the floor for a little bit, just to talk a little bit more about you. As mentioned, you did your master's and PhD, which was focused on sort of this really interesting area of ocean wave statistics and various dynamics of what's happening in terms of how ultimately we could potentially capture a wave energy from the ocean. Would love to hear about sort of the early days before Sargassum and what brought you up to this point.
Yeah, sure. Good question. So I love the ocean. I mean, I grew up in Trinidad. I'm from Trinidad. I live in Barbados now, which is the island right next to Trinidad in the Caribbean Sea. I was educated in the United States, and I feel like I grew up in the United States because I went from being basically a teenager to an adult coming back to the Caribbean, having gone through the US tertiary education system, which is very different from other regions, and how engineering is taught and what you believe by the end of your engineering education there. So I started off with this love for the ocean. I was studying mechanical engineering at Howard. And I think at first, a lot of us, this was around 2001, I started my undergrad degree. And a lot of us who went up to Howard, there were like 100 people from around the Caribbean region. And we all were so excited and enthusiastic about making a difference in the world. And yet the sky was the limit. And I think both myself and my best friend at Howard at the time, we're both from Trinidad, studying mechanical engineering. And we both kind of wanted to be rocket scientists. But after one semester at Howard, I was like, wait, stop. If I become a rocket scientist, I can never go back to the Caribbean region. And I think that was the start of realizing, okay, there's differences in our approaches. So my best friend went on to be a rocket scientist. But I said, you know what? What do I love? That's what I want to pursue. And I knew at that point I loved the ocean. And when I read the essay I wrote to get into MIT for grad school, I think is one of the most terrible personal statements for getting into graduate programs. I use it as a bad example when I'm training undergrads, like how do you get into grad school? I say, look at this terrible essay. Don't write this. But when I read it, I see how I used to think. And I love mathematics. I was good at physics, but I also love the ocean, and the idea of putting them together just seems so romantic, and it just seems so I don't know, something I wanted to do. And I did that. I pursued the mathematics of the ocean. I pursued looking at something seemingly so complex, but adding structure to how you think about it, and putting it in a context that's understandable. My PhD thesis topic was about stochastics of ocean waves towards applications like energy systems floating in the water, structures in waves. My last chapter, my PhD thesis was on wave energy. And you skip forward now, so that I spent 10 years at that point. It was 10 years I spent in the United States between undergrad and figuring out grad school, and then starting off this thesis at MIT, which when I started it, it was intended to be a PhD thesis. But through the process, I realized, okay, I actually want a shift and a change, and I moved back home to Trinidad. At that time, I had one young son. He was one. He was less than one when we moved back to Trinidad, and we had our second baby on the way. And we moved to a house pretty near to the University of the West Indies in Trinidad.
Mm-hmm.
And after a few months of being home and figuring out what do I really want to do, I thought, oh wow, I could run to the University of the West Indies campus from my house. Maybe the plan should involve this campus and moving this thing forward. And yeah, I took my same basic question that I had started at MIT and met an amazing scientist there. Her name is Jackie Bridge. She's now senior lecturer at the University of West Indies, St. Augustine. And she looked at the thesis and she's like, yeah, let's finish this thesis. And I worked with her at the time. So we were using mathematical chaos to describe the ocean surface. And why were we using that too? Typically, when you try to understand ocean surface waves, supercomputers are needed. At that time, at least, everything's different now, but that was 2005, 2006. Okay. At that time, you needed big tens of thousands of CPUs. And we would sign into military like supercomputers in Washington, D.C. from MIT to do this work to simulate ocean waves. And while I was doing that work, which became a master's thesis, I said to my advisor, why can't we find a way to describe this mathematically? I'm sure there's a way we could do this. And we ended up pulling in a math professor and looking at this question of what is a mathematical tool we could use to understand this behavior of nonlinearity in ocean waves. And we decided chaos theory was what we would use. And chaos says nothing really is random. Everything is deterministic. And you could describe the way probability works using something deterministic. Sorry if this is getting too technical, but pretty much.
That's great.
Okay, good. So pretty much what we wanted to do was describe things like rogue waves or unexpectedly high wave energy using math. And the math tool we used was Wiener chaos expansions. So now I'm at the University of the West Indies in Trinidad. And when you leave a place like MIT where there's a math library with 3 floors of just books on mathematics, and you come down to this little tiny island in the middle of the ocean that nobody ever heard of, Trinidad. And we have a small university campus. I walk on the campus and I do feel that inspiration. And I do feel like, oh, wow, I'm back. I'm swimming. I'm back in my environment, back in Trinidad. And it's not the same as MIT. And one of the things that's different is now you have to be cook to captain. Now there's not just one person specializing on floating offshore wind farms. No, yeah. The person who does floating offshore wind farms also does, I don't know, material science. and also does teaches 5 courses an academic year also. So I ended up getting really grafted into the academic community at UWI. I started teaching soon after I finished my PhD while full-time staff at the university there. And in that process, hired a lot of undergrad students doing their capstone project to
Right.
continue doing wave energy research. So I started doing cool wave energy research at the University of the West Indies in Trinidad. We were building devices and talking about in the Caribbean Sea, we have small ocean waves. And so when these people in global north, the North Americans, the Europeans, when they're looking at wave energy, they go after big waves. And they go to Portugal or they go off the coast of South Africa and they find these big waves and they test devices. And I'm like, well, we don't have that. So what are we going to do? And so we started looking at, okay, we need to build wave energy devices for small waves. And the beauty of Caribbean sea waves is they're like textbook waves. They behave like the waves in a first year graduate course on waves. So it was nice to look at an environment that was like I was showing off to my old MIT lab mates and saying, well, now the Caribbean Sea is my toe tank. And that was funny, but it was true. The waves in the Caribbean Sea did behave like simulated waves in the lab because it wasn't only big tidal signal like the waves in the North Sea and high latitudes. So we have nice behaving waves. We have like 200 undergrads every year who need to build and design and do projects. So I had a nice staff and resources coming through that allowed me to keep doing wave energy research in an environment I loved, and I felt like this is my space. I mean, I had a young family when I decided to leave Boston, but the thing that happened in the time I spent at MIT is I started to see my skill as a scientist and as an applied mathematician can help problems in real life. I'm not just in some ivy tower. I'm actually looking at the life around me and attaching my intelligence to the needed solutions in the life around me. So boom, I learned that thinking process, and then I'm supplanted from there and put back into the environment where my 2 young children could have grannies and cousins and just have a healthy life of a child. But I come back with this sight of solutions and this sight of the world that I learned 10 years in the United States. And I guess what happens next is just a marriage of those 2 things. And so around 2018, I think I finally defended my thesis around the same time the university here in Barbados needed staff and to teach renewable energy. And I guess people got word of some of the stuff I did in the lab in Trinidad, the island next to Barbados. And I applied to that job, and I guess the rest is history. We came to Barbados, all of us, on January 1st, 2019, and started looking at problems here around energy. And the thing about Trinidad is oil rich. We produce natural gas, we produce oil, and so there's no need for renewable energy there. And so a lot of the work I was doing, I saw it as solutions, but the rest of Trinidad just thought, well, that's so cute. That's so like unicorn kind of, wow, people do that. That was the reaction I got in Trinidad to my research. They're like, wow, there's people here doing that. When I got to Barbados, immediately you're seeing electric cars on the road, you're seeing solar panels on houses, you're seeing your electricity bill, and you're like, there's no way I'm gonna leave this light on when I leave this room. So energy is more expensive, is more scarce, and so we ended up basically all the work I did as an academic at the university suddenly was relevant to real life outside the campus in Barbados. And so, yeah, I mean, same thing. I'm working with undergrads and we answering questions about real life. And one of the things we tried to do was look at biogas as a solution for transport for Barbados. And we were thinking of sugarcane, which is typically and traditionally the feedstock you might expect from a place like Barbados. But sugarcane was not the answer.
Right.
Barbados is a tiny little island, by the way. We are 400 times more ocean than land. And the idea of growing a feedstock on land for biofuel, just for many reasons, seemed like not a solution for Barbados. And so it's really the students and in conversation that they mentioned, well, there's this sargassum seaweed. And I started to look at it more. And I mean, between the lab experiments we did that summer and things we learned about Barbados and the energy needs, it just more and more seemed like a sensible solution for Barbados to take this oceanic biomass in a country that's 400 times more ocean than land, take an oceanic biomass and make it a biofuel crop. And so we've been working with biogas as a demo that you could get energy out of this. This MIT scientist, and obviously I'm not stopping at biogas, but it is the lowest hanging fruit. Everybody's garbage can makes biogas every night if you don't take the garbage out. So biogas is a low hanging fruit in terms of the required technology to produce this energy source.
Right.
And so I think you might have heard of us because of Test Drive Zero, which is the first demo of a car driving on this biogas from Sargassum. And the point of it was this, so that it would just bring visibility to this solution. We've since incorporated a spin-off company from the university called Rum and Sargassum, where we use rum wastewater available in all of the Caribbean with Sargassum seaweed, also sadly available in all of the Caribbean, to produce biogas. And so Test Drive Zero, my principal on my campus, he was like, we need to do something. We need to demonstrate to the world this works. When are y'all going to do this test drive? And so there was pressure to show that the solution works because we are trying to scale up and commercialize now. And so I guess that leads to this. So on September 17th, we drove a car for the first time on biogas produced from Sargassum seaweed. It was an electric car. We use biogas we've made in a home biogas system imported from Israel. And the volume of gas it produces is like for a family to cook every day. But that was just about the right amount of biogas to put in a generator and charge an electric car and drive the electric car on it. My solution really is more practical, though, for Barbados. There's 150,000 cars here, and most of them are gasoline cars. And so our solution is to take the same biogas, take out the biomethane, compress it, that becomes compressed natural gas, put it in CNG kits and drive gasoline cars on the biogas. But a lower hanging fruit for Test Drive Zero was to charge an electric car. And I think that captures the imagination of many, to see a car driving on a seaweed that has become a crisis to many islands and tourist economies. And so, I think that might have been how you heard of us, from news that went out after Test Drive Zero.
Well, yes, yes and no, because as I mentioned before the show, I've been coming to Barbados since 1969, so I'm fairly familiar with the country, and I have stood on the cliffs looking over Crane Beach and seen the basically you couldn't see the beach anymore, because I remember the Crane Beach, for instance, being completely white sand in the 70s, and I was there a couple of years ago. I was like, where's the beach? It's
still there, by the way. If you go to the Crane Beach today, it's going to be white sand. Just a plug for the Crane Beach.
Right. No, that's exactly. So I followed your company because of that, but I was wondering, I appreciate everything you just talked about. I wanted to drill down on some of these points just so the audience further understands. I mean, and your prime minister too, Prime Minister Mottley, sort of declared Sargassum this national emergency a couple of years ago.
Yeah.
Talk a little bit about Sargassum, because we touched on Sargassum actually a couple of months ago with, of all people, Craig Venter of Human Genome fame. He was out there in the Sargasso Sea, sort of looking at microbes and things like that are hanging out on the Sargassum.
Right.
Where has this all come from? Because I know I saw this figure
Yeah.
that it has increased like a
Mhm.
hundredfold over the last decade. You got all
Yeah.
this fertilizer runoff in places like the Amazon and the Congo that are feeding it. But talk a little bit about it because itself is a very unique species in that, unlike, and correct me if I'm wrong, I'm talking out of place here, unlike other marine algae, this one sort of figured out, hey, we can like sort of float around and change our ways of getting nutrients and we don't have to hang out in sort of one place, and hence this genetically sort of led to this mess that's hanging out in the Atlantic Ocean. But talk a little bit about the sort of the biology of this stuff, if you would.
Yeah, sure. And you're hearing about biology from a mechanical engineer.
That's
Remember that.
cool.
So
I'm a
yes, you might
pharmacist, so I
correct me. But okay, so I mean, since Christopher Columbus came a long time ago, he saw sargassum floating on the ocean. So it's not like it just arrived,
right.
but in the volumes that we see it, yeah, so Christopher Columbus saw sargassum in Tobago and they've documented, like he described it.
Cool.
But um recently, since 2011, there's this Atlantic sargassum belt that's become stable. And so we have more sargassum now in the mid-Atlantic compared to the Sargasso Sea, which is in
Mhm.
Europe in the North Atlantic.
Yeah.
And so I guess for the past few years, maybe the past 6 years, scientists have been looking at using reanalysis from some of the Argus floats and just basically using satellite and floating local data to figure out where did it come from? Why 2011? Why did this uptick happen in 2011? And what stabilized it? And I guess I would say the long and short of it is it was the perfect storm, just many conditions that aligned. But there was specifically in 2011 atmospheric and oceanic current behaviors that strengthened this flow of the biomass from West Africa across the Atlantic to
Mm.
South America. At the same time, river runoff in the Orinoco Delta, the Amazon Delta, fed nutrients to the incoming sargassum. And then, I mean, once you get to that area of the Orinoco Delta runoff and estuary and also the Amazon, those currents just lead right up into the Caribbean Sea, and that's a closed gyre. If you look at the Caribbean Sea, it's just closed off by the China Islands.
Mhm.
So you're thinking of that area between the Gulf of Mexico and the Caribbean Sea, then it's closed. And so what happens is it stabilizes. You get this uptick in sargassum at the deltas, and then the currents take it into um, that closed oceanic area between the Gulf of Mexico and the Caribbean Sea. And so you get this stabilized input of sargassum at certain times of the year when the currents, the wind, the atmosphere, the oceanic current, and the atmospheric behavior align. So every year since 2011, it's gotten worse, more or less in a linear manner, except at one or two dips if you look at the data. And a lot of people are looking at sargassum as a stable source of biomass now. So I know of funding in the United States. I know of an ARPA project, different sources of funding, putting lots and lots of resources into understanding where did it come from, how stable is it, and we even grow it if we wanted it, a supply of it all year in a way that doesn't endanger the exclusive economic zones around it.
Got it.
It's just become a massive nightmare for
Mhm.
Caribbean islands whose economies depend on having tourists in beaches and in hotels like the Crane. You don't want rooms in the Crane empty ever for the Barbados economy.
Yeah.
And so I mean, so they
Right.
battled with it. And I'm sure when you were at the Crane and there was sargassum, they probably put you on a bus and took you to another beach. And it probably cost them. I know the Crane spends over 2 million US every year
Yeah.
in just responding to sargassum on their beach.
Right.
And that's just the Crane. There's hundreds of hotels like the Crane in
Yeah.
Barbados. And so you can think of the economic impact of sargassum on a beach. And every year, I mean, there's a cycle. I feel like it's bigger than an annual cycle because some years you see it in certain months and then it kind of shifts on the next year. But the data is out there, and sargassum is, I mean, 2023 was a bad year. It was on the beaches for 9 months in Barbados, and so it's become part of life, and understanding it and managing it is now has to be part of life, and it has to make economic sense, which is why our solution going after energy meets the crisis at the scale that it arrives. I think CERMES, UE, on my campus, CERMES, the Center for Environmental Research and Management, is tasked with managing the knowledge around sargassum, and they've done a pretty good job at studying sargassum, at documenting what has been studied. And I think between Hazel and Kim, who are two scientists based there a year ago, they estimated something like on a bad day in Barbados, more than 800 dump trucks of sargassum can arrive on the beach on one bad day. So when you think of that, when I look at my experimental results, that's over a month of all the energy needs in Barbados, not just cars, everything. So you want to be able to manage that arrival in a way that it'll cost a lot to intercept it. And so can the interception then be commercialized in some way? And I think energy is a nice energy easily meets it at this scale.
Right. Perfect. So now, laying that groundwork, so that biomass groundwork now, you publish a really important piece. This is in 2021 in the Interamerican Development Bank I guess the magazine, but it's experimental evidence for use of biomethane from rum distillery waste and sargassum seaweed is alternative fuel for transportation in Barbados. And here you go into a lot of what you were just talking about. Okay, we don't have a lot of homegrown sort of natural gas. We have a major tourism industry, and we don't want that disturbed. And now we have this amazing biomass source. Talk a little bit, because there's other pieces of this. There's the wastewater stream from the rum distilleries, which is using some of the sugarcane on the island. Put this together. So, because obviously we went from the biomass to the magic and driving the car, but talk a little bit about sort of what goes on in this circular system, because it's quite elegant. And I won't, talk much more of this because it is a really comprehensive report, and we'll put the link in the bio of the show. But take us a little into this, because it is a very elegant system, a circular system you put together here.
Yeah, thank you. So I want to start that part by saying the thoughts around this is really scientists on the ground in Barbados. So one of my team members and technical advisors is Felicia Cox, soon to be Dr. Cox, which is what we're working towards. She's actually my Ph.D. Student. I'm her supervisor. She's also an MIT graduate. Felicia has 2 MIT degrees. She got her undergrad there, graduated class of 02, and then got her master's there in class of 05. She graduated, and she's brilliant. And I think in a lot of conversations, because the thing is, these solutions happen in conversations. And so you think of a campus like MIT. MIT has more grad students than undergrads. I was never lonely as a grad student in MIT. Like, my grad students now on Cave Hill campus are lonely. They're like, no, I don't know who the other grad students are. When you go to MIT, there's more grad students than undergrads. You're always talking about research. There's always conversations. There's afternoon tea in the math department. They have afternoon tea at 2 p.m. every day. That's not spending money on cookies and coffee for nothing. They know collaborative research is happening in those conversations, and new ideas and new papers. A new program might spawn from an afternoon coffee cup. And it is in conversations with scientists that we kind of brained out and imagined the solution, and then kind of miraculously funding started to arrive on our doorstep, and we're able to make steps forward. Okay, but So I would say it was in conversations with undergrads in my E.N.Sc 2003 class, conversations with Felicia on a random field trip we had to the Barbados Energy Company, and she was a staff member there at the time, and different things. I would say almost fortunate events that happened that brought together the right people to think and talk through the solution. But one of the things we discussed was wastewater. And I mean, one day I just kind of picked up the phone. And the cool thing about having LinkedIn say, yeah, MIT graduates is everybody replies to your messages on LinkedIn. So, I mean, I ask people around Barbados, do you know the owner of X rum distillery or Y rum distillery? And it was actually easier to just reach out to people through LinkedIn messages and say, what do you do with your wastewater? Can I borrow some? And of course, when you ask somebody, can I borrow some of your wastewater? They say, yes, come now, come yesterday. Because there's nothing, they don't use the wastewater for anything. And they're under pressure, international pressure and local pressure to find uses for the wastewater. Right now, rum distilleries in Barbados either evaporate their wastewater, which is methane, into the atmosphere, or they treat it and then send it out to sea, out at sea. And so having uses for wastewater on land is an answer to a prayer of a rum distillery owner. And so we've tested wastewater from 4 of the major rum distilleries in Barbados, Foursquare, West Indies, Mount Gay, and St. Nicholas Abbey. We've tested all of their wastewater in this formula and found ways to get methane out of it in an efficient way. Why did we go after rum distillery wastewater? Rum is a big industry in Barbados.
Sure.
Next to tourism, rum is one of the Barbados industries. And rum wastewater is produced, there's 1 million liters of rum distillery wastewater produced every day in Barbados. And there's no actual use for this wastewater right now. And so this is a waste stream that needed a solution. And so the thing about anaerobic digestion, which is how we produce the biogas, is it is water intensive. You need water because basically anaerobic digestion is a bunch of little microbes moving around in a medium and digesting sugars and digesting, getting carbon from one form into methane. And so we needed a source of water. I knew from conversations that Barbados is water scarce. So if you're going to bring anaerobic digestion as a solution to Barbados, you can't say, and now this is the part where I take all your fresh water and put it in a digester. We were never going to say that. And if we had to say that, we would have just never pursued this solution. We needed wastewater. And the best option when you look at comparing industrial wastewater streams for biogas production, rum distillery wastewater is one of the best because it has sugar in it, because it has a nice microbial environment usually. And so those two things are great for biogas production. However, rum distillery wastewater is a little bit unstable because it is variable. It depends on the quality of the molasses. There's basically, in producing rum, one taste regime you want from whichever product. And you know the profile you want out of this product. And so you process until you get to your taste profile, and then you have wastewater left over. 5% is rum, 95% is wastewater. And so it comes not too varying, but in enough of a variation that the biogas out of it is not so predictable for just a rum distillery owner wouldn't go into biogas.
Right.
Because it's not just a matter of, okay, then now put my wastewater in a digester and I'll get methane out of it. It's usually unpredictable. And so co-digestion of the rum wastewater with the sargassum actually does levelize and make it much more predictable getting biogas out. And so it had to be a few problems lining up. The stars had to line up for the solution because, I mean, a lot of people have asked me, well, why didn't the rum distilleries think about this a long time ago? And the answer is they had thought of it and they've tried and it hasn't worked. the way it's worked for us with Sargassum because co-digestion added to this predictability of the output.
Well, again, it's quite elegant, and we will put the link to the report per the IDB on in the bio of the show. Sort of, Lydia, that brings us up to, as you're in September 17th of this year. You do the first test drive, and again, it wasn't just you hanging out driving the car. I mean, you had folks from USAID, Senator Lisa Cummings from the Minister of Energy, obviously the Mia Mottley administration is clearly not very pro, sustainable development goals, but clearly, for advancing small developing island nations in technology. What sort of happens now? I mean, clearly you had the successful drive. I saw a really nice rendition of a charging a biogas station, which we would love to see that exponentially grow all over the island. What are the next steps to bring the station online, bringing many stations online? And then there was also this cool little poem. I don't know if you wrote this, but all about the development of the technology. We could say a couple words about the poem too. That's kind of cool. But what's happening now as we sit here on the cusp of 2025 for scaling this up?
Right. So we don't well, here's what we know: it will take partnership to go to the next step and to go forward. And so since Test Drive Zero, my life has been many meetings with many funders. The scale of funding needed to go up to the next level is something like to provide, I think, based on all the current wastewater in Barbados and the Sargassum availability, you could get something like an 8-megawatt biogas plant on the island, and obviously coastal because there's a lot of Sargassum to get into the plant. So 8-megawatt coastal biogas station would be ideal, and we know the cost of that is in the neighborhood of around 26 million US dollars. That is compared to the equivalent in, say, eastern parts of Germany, it would cost around 20 million euro to get the same size biogas plant. So I had a recent trip to Germany, funded by GIZ, which is a big German international bank, and so I've visited a few biogas plants in Germany this year. And so seeing is believing, and it was nice walking around in a biogas plant at that scale, with a clear understanding of all our lab testing and our small system. Right now, the next step for us that we're really going after is two things. We're trying to get about a 250 kilowatt plant, which would power that gas station to provide transport fuel to around 300 taxis in Barbados. And taxis drive a lot here because of tourism. Sure. A taxi driver drives something like 6 times the amount the average person drives. So the average person in Barbados drives 35 kilometers per day. And in taxi language, you multiply that by 6. And so having 300 taxis is kind of like almost having 1,800 customers in a pilot. And so we're going after that. It's not going to be hugely profitable, but it will demonstrate and help us to understand revenue in this business stream. It will be moderately profitable at that scale. But I think in terms of the energy need in Barbados and what is available through Sargassum, you could get an 8-megawatt biogas plant. I would say, so what we've been doing recently is thinking about bridges to what's the reality now to get us to that point. So one thing is, it would be great to have a few cars in Barbados with CNG kits in them. For my pilot, so the image you've seen, and we're actually 70% finished setting that up. My team, we've just been going there and every day making progress on that. We have a 4-car pilot. So basically we're producing enough gas for 4 cars to drive on, and we have CNG kits in 4 cars in Barbados, including my car. And so yeah. So the next step is we're gonna have cars driving around Barbados, and we put little stickers on them saying this runs on Sargassum, and this will be gasoline cars. We have the electric car which we charged a couple times using Sargassum, and this is the next thing. You might have seen some tweets from the EU. We went to Grenada a few weeks ago and had discussions with the EU about potentially providing scale-up funding to pilot this kind of idea somewhere in the Caribbean. And so those discussions are ongoing. We've applied to USA DIV for $2 million US, which would help us to really optimize the current pilot with the 4 cars, but also get CNG kits into some local cars that we could get them ready to receive our biogas. The thing is, the biogas is producing renewable natural gas, which is compressed biomethane. It's the same as regular fossil fuel natural gas. So if you have cars with CNG kits in them, in the meanwhile, they could drive on natural gas while we get our biogas at production scale, and then they'll be our customers. So that's one of the next steps, a practical low-hanging fruit for us as a company. And then understanding the region. So another thing I've been doing is trying to understand, okay, in the context of a Grenada, of a St. Vincent, how would this work?
Right.
Trinidad is oil rich. It's probably never going to work in Trinidad. But definitely they have so many CNG cars. There's 13,000 CNG cars in Trinidad. So we've worked with Trinidadian knowledge around natural gas use, because that's what we're producing. We're producing renewable natural gas. And so that has been the rule of Trinidad so far. I mean, the Trinidad National Gas Company was one of the sponsors of Test Drive Zero. And so it has become this regional facing solution. We've also run an experiment in San Diego using San Diego Sargassum and also San Diego kelp and Bear Brewery wastewater. So my PhD student spent a semester out there. I think it was 4 months she spent out in San Diego 2 years ago. And so, yes, we are looking at scale up. And scale up means figure out how it works in other jurisdictions. Honestly, one last thing I'll say is this. Sargassum is a global problem. It's not just a Caribbean island, cute little island in the middle of the sea problem. Florida is struggling with Sargassum. Mexico is struggling with so there's a problem in Central America, parts of North America, parts of West Africa. I think of it as a global crisis. And so truths about our solution, innovations around our solution that we commercialize can actually be commercial in various parts of the world. So it is a Barbados birthed solution, which I'm very proud of. I studied in MIT, and I've seen the massive might of big countries and big country innovation and the pride around that. And I've seen people dismiss the idea that a solution birthed in Barbados could have an impact on the world. But I think differently. And I think I believe in, I guess people think I'm a mystic. I believe in purpose and things, something beyond us. And so the fact that I studied in the US, ended up in Barbados, not Trinidad, but Barbados, where we have a Mayor Mottley, who I think is a really innovative prime minister. When you put her next to world leaders, I see her as an innovator, as a forward thinker. I think all of it comes together in a way that makes me think there's something beyond just us driving a car on Sargassum in Barbados, something that can have global reach, and we'll see how that goes. But right now we're at a point where we're trying to find scale-up funding, and we do so by demonstrating cars driving on Sargassum and having lots and lots of meetings with funders.
Right. No, it's again, it's exciting times, and clearly, you take things to the next level and start talking about those numbers. But nonetheless, it's not like not like you're asking for $1 trillion to do something, right? I mean, this is all very feasible, and so no, that's one of the many reasons I'm excited for you. Going back for a minute to Prime Minister Mottley, one of the things that putting aside the renewable energy that she's been a very outspoken proponent of, and has been on a lot of these committees as we've been talking about this theme of antimicrobial resistance. And she's been leading the charge on that front as well, sort of the silent pandemic that no one's really paying attention to. It got me thinking of a lot, when you go into the PubMed database of the NIH and you put in Sargassum, you get something like 2,000 papers back of all the antimicrobial and antiviral and anti-cancer sort of effects of some of the small molecules that are found in sargassum. And I know, again, I'm a pharmacist talking to a mechanical engineer here, but any interesting sort of co-development opportunities that come along, whether it's pharmaceutical, cosmetic, nutritional things that spill off of this. But, you talk about the co-fermentation and all that, but there's other things that pop out, I guess, of the processing along the way. And just interested if you give it any thought. I mean, obviously thinking about a bunch of other things, but to some of these sort of other value-added products that sargassum gives you while you're turning it into energy.
You
What did?
asking about other products and
Yeah,
basically synergies with our solution
yeah,
and other products. So I'll say this. We're not after the high value product, and I could see us collaborating where somebody wants the pharmaceutical or even cosmetics, plastics. There's been all kinds of solutions like that, and I met a lot of those people in Grenada a couple of months ago. But we use everything in the sargassum biomass, and so I could see there's an opportunity for crossover with other solutions where whatever they have left over, we can put in our biodigesters and get biogas out of what's left. So there's that. On my campus, there's been research on this pharmaceutical and other types of solutions. So I'm not the only sargassum innovator at my university campus. There are a few others, particularly within the Faculty of Science and Technology, biosafety, etc., that have been looking at other sargassum solutions.
Got it. While we have you, any other final? I mean, I know that you also have done research on OTEC, thermal energy components of what's going on in the Caribbean. Anything else that's interesting or hot coming up for 2025 while we have you today, please take the floor.
Yeah, okay, great. So, I mean, yeah, just to speak to the last thing I said about solutions from these small spaces actually potentially having global impact. I just want to say that even at UWE Cave Hill, there's lots of world-class scientists I particularly appreciate the work in Surmies in advancing this understanding of sargassum. I mean, if you want to see predictions of the next few months of sargassum, Surmies has a sargassum prediction bulletin that they've generated. We have scientists on campus looking at predicting sargassum arrival in ways that could help industry and solutions like rum and sargassum. And beyond just the sargassum solutions, there's a lot of novel work happening at the campus, particularly, I mean, I'm very much aware of my Faculty of Science and Technology and innovations happening within UWE Cave Hill Faculty of Science and Technology. And I really celebrate, I mean, we have a lot of events for one UWE and the different campuses on the different parts of the Caribbean, but particularly I enjoy being at Cave Hill and being in that very innovative environment of UWE Cave Hill. There's something about having the ocean just right there. Everywhere you look, you can look outside and see the ocean. That makes people creative, and bright people get brighter. So I think I celebrate UWE Cave Hill. It's been a great home for me, and I've met a lot of impressive people here. And I think one good thing about rum and sargassum is just the visibility that our campus Just, I guess, one of these things that came with it is people have looked at, well, wow, what else is happening at this campus?
No, it's again, it's an elegant set of solutions you put together there. I love I love it. I love Barbados, and so it's so nice to see this all coming together under your watch. And I really, wishing you and the team the best with it as you continue to move it forward and scale it as we head into 2025. Again, for everybody that's going to be listening to this episode across the podcast networks or watching on our YouTube channel. Again, you've been spending time with Dr. Legena Henry, Chief Executive Officer and founder of Rum and Sargassum Incorporated, also lecturer renewable energy at University of the West Indies Cave Hill campus in Barbados. Legena, I really want to thank you for taking the time out of schedule today to talk to us for a little while about everything you're up to. Obviously, thank you for what you do for science and technology advancement. And as we like to say on our show, thanks for helping to create a better tomorrow via the type of technology you're championing. Really an awesome story, and wishing you and the team the best with it.
Thank you. I appreciate it. Thanks for having me. It's been an enjoyable conversation.
Yeah, it was really a fun conversation.